8 points are spaced around at intervals of 1 unit around a 2x2 square as shown. 2 of the 8 points are chosen at random. What is the probability that the 2 points are 1 unit apart? So we have a 2x2 square as shown, and 2 of the 8 points are going to be chosen at random. And what is the probability that the 2 points are going to be 1 unit apart? So first, if we choose 1 point, then there are going to be 7 remaining points that could be chosen as the second point. So if we start with scenario number 1, we could choose a point that is in the corner. We could choose a corner point, since there's going to be two dots in the middle that are 1 space apart. Or we can have another scenario. And in this scenario, we're going to be choosing the middle points. And we can do this because there's going to be also 2 points that are 1 space apart from these points that we choose. So if we go on calculating the probability of this, we're going to have 8 total ways to choose a point first. So we have 8 ways to do this. And then there's also going to be 2 ways to pick a second point for this, so that the distance between them is 1 unit. So 8 times 2 equals 16 total ways to pick such pairs. But since we're counting each pair twice, since for example if we count this one, so it's going to be the 1 unit across is going to be this point, but if we choose this point first, then the 1 unit across is going to be this point, so they overlap. So we're counting the duplicates also, and since we want to reduce that or eliminate that, we're going to divide it by 2. So we have 8 total ways to pick such pairs. And then the total number of ways we can pick any points in this diagram we have over here is going to be 8 total points, choose 2, since we're choosing 2 points. So 8 choose 2 is a combination, and for those of you who don't know how to do combinations, the general formula for that is k choose n. We're going to have k factorial over k factorial times k minus n factorial. So if we do an example with the current situation we have, it's going to be 8 factorial over 2 factorial times 8 minus 2 factorial. If we solve that, it's going to be 8 factorial over 2 factorial times 6 factorial, which is going to be 28. So we have 28 total possible combinations. And 8 of those ways are going to be the requirements that we must fit. So it's going to be 8 over 28 total possible combinations, which reduces to 2 over 7. So our answer is going to be B.